Hello friends, welcome to the course Essentials of Data Science with R Software 1, where we are trying to learn the topics of probability theory and statistical inference, and now we have begun with the topics of probability theory. So, can you recall that in the last lecture, that was a very storytelling type lecture where I had tried my best to give you some idea about the probability theory, and I tried my best to convince you that probability theory is not a new thing for you that you are going to learn. You already know it. The only thing is that I want to now define it in a mathematical terminology. The advantage will be once you are able to show someone that this is how you are trying to compute the probability, not your friend, but this entire world will agree with you. That means you will be able to develop a very good probability model, and that is the basic objective of data science. So, now from this lecture I will try to take a very small issue, very small ingredients, and I will try to move towards the construction of a probability model. I will try to take very small topics, elementary topics, and I will try my best to give you or to explain you in a very simple language. But definitely when you are trying to learn it, you have to keep in mind there is a very strong theory behind these concepts. My objective here is very different. I am trying to connect the statistics with the data science, and data science is heavily dependent on the computer, and for that we also need a software. So, now at this stage I will be not that much interested in giving you the theoretical construct, but I will be more interested in the application part of the tools, and for that whatever are the basic ingredients I will try to explain you. That is my objective. In case if you want to know the hardcore theory behind these topics, I will simply suggest you pick up any book of statistics and try to learn it. Right. So, now in this lecture we are going to talk about the first basic ingredients of probability theory, which is sample space and events. So, let us begin our lecture. Right. So, now if I ask you a very simple question, you know the answer. What is an experiment? How do you define an experiment? This is the first basic terminology which is needed for the probability theory. So, I can say that any activity for which the outcome is uncertain can be thought as an experiment. You always try to toss a coin or roll a dice. Do you know that before tossing the coin, what will you get, head or tail? Certainly not. That you come to know only after the experiment is completed. Do you know that if you start from your home at certain time, at what time you will reach to your college? Exactly. You always tell only the approximate value. Means if it takes about 20 minutes, then if you start from home at 10 o'clock in the morning, you may reach to your college at 10:18, 10:19, 10:20, 10:21, 10:22 and so on. So, what is that? That is also an experiment, that before reaching over there you do not know how much exactly the time you are going to take. And the uncertainty in such event concerns in the sense that the outcome of the experiment is not known unless and until the experiment is completed, and the outcome is not predictable with certainty in advance. That is why they are called as experiment. You are trying to conduct an experiment, then you understand the meaning of it. You will never say that you are going to conduct an experiment to see whether the sun rises in the east or in the west. That you know. In case if you try to combine two chemical known compounds in a given quantity, you know that what is going to be the outcome, unless and until you are trying to create an experiment, because an experiment you will not be knowing that what is going to be the outcome, right. Whatever the experiments, chemical experiments we try to do in our class 10 and class 12, we know their outcome. And whenever you are trying to combine two chemicals and if you are not getting the same outcome, possibly you try to repeat the experiment because you know the outcome, but that is not really an experiment. The experiment will be something like people are trying to experiment for the COVID vaccine on different types of patients, where they do not know before the conduct of the experiment that whether the vaccination is going to work or not. Right. So, similarly, I can take here some more example. For example, when you are trying to draw a card from a deck to observe which card is drawn, you do not know unless and until the card is in your hand or the card is drawn. Similarly, if you toss a coin, you do not know what is going to turn up, head or tail. That is an experiment. But remember one thing, probability theory is beyond the tossing of coin, rolling a die and drawing a card from a deck. Right. Probability theory is now happening in your day-to-day life. Now you should be convinced about it. Well, we are trying to take very simple example to explain you, at least you know that how to toss a coin or how to roll a dice. That is the reason we always take the example of tossing a coin or rolling a dice, but you should not laugh or you should not feel that okay, why probability theory is always happening with tossing a coin. Okay, so now we try to introduce or try to understand two terminologies. One is sample space and another is event. Whenever you are trying to conduct an experiment, the outcome of the experiment is not known to us in advance. But in most of the cases you will see that we assume that all possible outcomes of the experiment are known. For example, in case if you try to toss a coin, what will happen? Either there will be a head or there will be a tail. Similarly, if you try to roll a dice, what will happen? Either there will be 1, 2, 3, 4, 5 or 6. Right. Even if you want to go from your home to your college where you know that approximately it takes 20 minutes under the general condition, then what will happen? You know that it will take time, say 17 minutes, 18 minutes, 19 minutes, 20 minutes, 21, 22, 23, 24, 25 minutes. Yeah, unless until there is some major issue. So, we do not know at what time I am going to reach to my college, but I know with a very high possibility that okay, in any case I will be reaching between 15 minutes to 25 minutes. Right. Similarly, when you try to go to your exams, you do not know before the conduct of exam that what type of grade are you going to get, A, B, C, D or F, but definitely you know for sure that what are the possible outcomes. A student can get a grade A, B, C, D or F. So, the set of all possible outcome of an experiment is known as the sample space of the experiment, and it is indicated by the symbol capital omega. Capital omega is a Greek letter, just like we have capital A, B, C, D. So, we have capital W and the capital W in the Greek letter is capital omega. And now, when you try to take a subset from this sample space, this is called as an event. How? Suppose if I say you are trying to toss a coin, the possible outcomes are head and tail. But now, can you say that there are two possible events? One can get a head or one can get a tail. Similarly, if you take about 15 minutes to 25 minutes to reach your college from your home, can I say that I want to know that what are the chances that you will reach there between 18 minutes and 21 minutes? So, what are these? These are the subsets of the all possible values. So, any subset of the sample space is known as an event, and this is denoted by say here capital E. That is the symbol what we are going to use in our course. So, now if you try to think that whenever you try to read such definitions in the book, many times you get badly confused that what are they trying to see, or what are they trying to show you. But if you try to understand them, just spend couple of minutes and try to see what are they trying to explain you, the things becomes very simple. So, an event is a set of possible outcomes of the experiment. And if the outcome of the experiment is contained in E, that is the subset, then we say that E has occurred. For example, if a coin is tossed and the sample space has 2 points, head and tail. Now, in case if I try to toss the coin and suppose it comes head. So, head you can see that this is one of the point that was available inside the sample space, and then we can say that an event has occurred. And what is that event? The event head has occurred. Yeah, that can also be that the event tail has occurred. So, any outcome that has to be contained in E, right, then we say that the event has occurred. For example, if there is a hospital where people are trying to record the gender of a newly born baby, newly born child. So, there are only 2 possibilities that whether the child is male or the female. So, in case if you try to collect these 2 possible outcomes, then together they will try to constitute the sample space capital omega. So, here for example, M is indicating that the child is male and F is indicating that the child is female, right. So, now when somebody is going to the hospital, the person will say that the sample space consists of only 2 points, male and female. Now, whenever there is a baby born, then whatsoever be the gender of that baby, that can be either male or female. So, in case if the baby is male, then we say that E consists of M, and then E is the event that the child is a male boy. And similarly, if E consists of only F, that is the baby is female, then we say that the event E is that the child is a female or a girl, right. Similarly, if I take another example, if there are 3 students who have got 3 positions in the game, means if there are 3 students and they are trying to participate in a game, there are only 3 possibilities that the student can get the first position, second position or third position, right. Now, the experiment is conducted and those 3 students try to occupy the positions 1, 2 and 3. Then what will be the sample space? Sample space will consist of all orderings of the number 1, 2 and 3. Why? Because there are 3 students and those 3 students can occupy the places in different orderings. For example, the most simple one will be first student get first position, second student get second position, third student get third position. But do you think is it the only possibility? No. First student can get the third position, second student can get the first position and so on. So, in case if you try to see, there will be different combination possible 1, 2, 3, 3, 2, 1, 2, 1, 3 and so on. And in case if you try to collect all such ordering, they will try to create the sample space. Now, in case if you try to understand what is an event or how are you going to interpret it, suppose the outcome is here 2, 3, 1. This means student 1 has got the position number 2, student 2 has got the position number 3 and student 1 has got the position number 1. So, now in case if you are getting an outcome like 3 to 1, then this is an event. This means what? That student 1 gets position number 3, student 2 gets position number 2 and student 1 gets position number 1. This is the meaning of this 3 to 1. So, this is an event. Right. Similarly, if I try to take one more example, suppose an experiment is conducted and we want to know the dose of a medicine. Suppose if somebody wants to conduct such an experiment, what the person has to do? The person has to give a certain amount of dose to the patients and the quantity of that medicine or the dose is increased continuously, and it is continued until the patient reacts positively. You have seen that somebody has got a body temperature. First the doctor says, okay, give half tablet. Then if there is no effect, they try to increase it to 1 tablet. And if there is no effect, they try to increase to 1.5 tablet and 2 tablet and so on. Right, definitely they will try to do up to only that level, up to which the medicine is not harming the patient. So in this case, what will happen? One possible sample space for this event is to assume that let omega consist of all the positive numbers, right? Because those can be any value between 0 and infinity. Well, infinity is something like a symbolic, but it is going to be positive, right? And what will be the outcome of such an event? The outcome will be can be denoted by some value here, small x, which is the value of the dosage that is going to help us, or that is going to help the patients, that if the patient starts getting this dose and reacts positively when the value of dosage reaches to x, and as long as the dose was smaller than x, there was no reaction, there was no improvement, the medicine was not working. This is what we mean. So now you can see here that understanding the concept of sample space and event is not difficult. The only thing is this: you have to think and decide yourself for a given experiment that you are trying to conduct, that how are you going to define the sample space and objective. One thing I would like to clarify here very clearly, that the definition of a sample space and events are related to the objective of your study. It depends what you really want to do. For example, in case if you are trying to roll 2 dice, then there can be different objectives in which you might be interested. For example, you want to know the sum of the numbers on the upper faces of the dice, or you want to know the difference, or you want to know the sum of their square, whatever it is. So it depends on your objective what you want to do, but my advice is that try to understand the experiment, try to understand the need of the experiment, that why the experiment has been conducted, what you really want to know. Based on that, you try to define the objective, and based on that you try to take the definition and try to decide what is your sample space and events, right. So now we have understood this concept, but we need to indicate it by some mathematical terms so that anybody can understand it, right. So now whenever we are trying to conduct an experiment, the outcome of a random experiment is called as a simple event or an elementary event, and it is denoted by small omega. You can see here I have introduced here a word random experiment. You see, whenever you are trying to conduct an experiment, as we discussed earlier, we do not know what is the outcome, what is the possible outcome that you are going to get. Well, the total possible outcomes are known to us, but out of them which of the outcome is going to come, that we do not know. That is, in that sense, we call the experiment to be a random experiment. So now whenever we are trying to conduct an experiment, there can be more than one outcomes, and suppose there are k possible outcomes which are indicated by say omega 1, omega 2, say omega k. So now in case if I try to collect the set of all possible outcomes of omega 1, omega 2, omega k, then they are going to constitute the sample space omega. So now you can see here, whatever you have explained the concept of omega in these 3 examples, this medicine example, this student's example, and this male and female child example, that omega is now well defined, right. For example, if you try to take here this example of say male and female, this omega 1 can be capital M and omega 2 can be capital F. And similarly, if you try to take here this example of medicine, means any value of the dose of the medicine that is reacting to help the patient in curing him or her, that is your omega value, right. In this case, the value of omega can be in some interval form also. So now the subsets of omega are called event, and they are denoted by capital letters in general. capital A, capital B, capital C and so on. But that is our convention, right. That is our understanding, and at least in this course we are going to follow this convention. Now, I try to make the things more clear and we try to define it in a mathematical symbol, because once you try to define the things in a mathematical symbol, the things become very easy to understand. Now, suppose if you want to compute the sum of squares of the first 100 natural numbers, then I can write down here 1, 2, 3, 4, 100, then I try to square them, then I try to sum them and so on. All those things I can write down very easily here. X goes from 1 to say 100 summation x square. So, you can see here mathematically you can express these things very compactly, which anybody can understand very easily. Right. So, with this point of view, I try to express whatever we have discussed, whatever we have understood in a mathematical symbol. So, now I try to define here two things: complementary event and Shor events. So, let this capital omega A, this is the set of all simple events that are contained in the event A. So, that means anything can happen from this set. Whatever cannot happen, that is also another set, and that event which cannot occur in this omega A, this is called as a complementary event or a composite event, and that is indicated by A bar. Sometimes you write down here A complement also, whatever you want to write, different books follow different symbols and notation, that is not a big deal, but here we are going to denote it by A bar. So, this is also an event and this is referred to as non-occurring of the event A, and it is called as composite event or complementary event. So, you can see here that capital omega, this is the entire sample space. Sample space consists all possible outcomes. So, do not you think that omega is also an event? Yes, omega is an event, and since it contains all possible outcome, we can say that omega will always occur and it is called as a sure event or certain event. Suppose there is a coin, there are two possibilities, head or tail, and if I say, well, what is the probability of getting head and tail or head or a tail? Can you tell me? This is a joint event, means I just want to know that if head comes or tail comes, I will be very happy. The probability is always 1, because there are only two possibilities with that either head will occur or tail will occur. So, when my event is comprising of both the events, the probability of this event will always be equal to 1. For example, if I roll a die and then there are 6 possible options 1, 2, 3, 4, 5, 6, and if I say what is the probability of getting 1, 2, 3, 4, 5 or 6, that is always going to be 1. Well, definitely one of the point is going to occur, so such points are called as sure event. Now, when you have a sure event, then definitely there has to be an impossible event also, because sure event is occurring always. So, impossible event will never occur. So, in case if we consider the set here phi as null set, that means there are no elements, and this is also is an event. So, then this event can never occur and it is called as an impossible event. So, if you try to see, the sure event is the set of all elementary events and the impossible event is the set with no elementary events, and sure and impossible, they are complement to each other, right. Okay. So, now I try to take a very simple example and I try to explain you these concepts. Suppose I try to roll a die, and suppose the die is rolled only once. So, there are 6 possible outcomes. For example, you know that if there is a die like this one, there are points like here 1, 4, 1, 3 and so on. So, if this dice is rolled, then what we try to do? We try to observe what is appearing on the upper surface, right. You must have played very means different type of the board games from your childhood. So, now in this case if you want to define the sample space, then there are 6 possibilities getting 1, 2, 3, 4, 5 and 6, and I have denoted all these 6 values by event omega 1, omega 2, omega 3, omega 4, omega 5 and omega 6. So, omega 1 is the event that 1 appears on the upper surface, omega 2 is the event that 2 appears, omega 3 is the event that 3 appears and so on. And this capital omega is going to be the collection of all possible events omega 1, omega 2 up to omega 6. Now, I can define the event according to our objective. Suppose if I define the event A as an even number of dots on the upper surface of the die, then there are 3 possibilities that the event occurs with this event, because the number are going to be even, then either 2 can occur, 4 can occur or 6 can occur. So, that means they are corresponding to omega 2, omega 4 and omega 6. And what will be the complementary event for this event A? If event A is asking that it is trying to consider all even numbers, then obviously the complementary will be consideration of all the odd numbers, right. So, the complementary event of A will be denoted by A bar, and this will be if an odd number shows up, then we have a complementary event, and there are 3 possibilities. What are those possibilities? Whether you observe 1, 3 or 5, and these are the 3 events which are indicated by omega 1, omega 3 and omega 5, right. So, this is how you can see that you can define these things. Now, in case if you want to define here an elementary event, then this elementary event is an event defined to observe only one particular number. Say for example, omega 1 equal to 1, then it is an elementary event. If you try to take omega 3 equal to 3, then that is also an elementary event. And what is here the sure event, which is 100% guaranteed to occur. Sure event is the event that a number which is greater than or equal to 1 occurs. Why? Because any number between 1 and 6 is greater than or equal to 1. So, whatsoever number come, the event is always going to occur. So, that is a sure event. When we have a sure event, then we also need to understand what will be the impossible event. So, in this case, for example, we can define an impossible event like this is the event that the number 7 appears on the upper surface of the die. Do you think that number 7 can occur? There are only 6 numbers, at least we have assumed that we have a die which has only 6 numbers 1, 2, 3, 4, 5 and 6. So, this event can never happen, and this is called as an impossible event. Now, I try to change my objective, and suppose I try to say that I am going to roll 2 dice, and we try to throw both the dice simultaneously like this one. So, our outcomes are going to be like this one, right. Suppose if there are 2 points here and here there are 3 points on the second die, right. So, and if I try to write down the number of points on the upper surface, suppose this is my dice number 1 and this is my dice number 2. So, I can write down here the value here say 2, 3. Suppose this is an event that whatever numbers we are going to observe on the upper surface of both the dice, that is my event. So, this is what I have defined here. Now, how many possibilities are there? If you try to create here a small table like as 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. You can see here 1 comma 1 can come, 1 comma 2 can come, 1 comma 3 can come, up to here say 6 comma 1 can come, up to here 6 comma 6 can come. So, there will be altogether 36 possible outcomes, right. So, there are 36 simple events which are defined as the number of dots on the first die, number of dots on the second die, and they are indicated by omega 1, omega 2 up to omega 36. right. So, omega 1 means 1 and 1 occur on the upper surface of both the dice, 1 2 means 1 occur on the dice 1 and 2 occurs in the dice 2 and so on. So, now if you try to see, the sample space capital omega will consist of these possible values, and these all the collection of all such events or the sample point that is creating our capital omega. So, now you have obtained the sample space also. Now, from this experiment I can have different types of objective and I can define different types of events also. For example, if an event A is defined as upper faces of both the dice contain the same number of dots, then what do you think? What will be your capital omega A? That means the sample space corresponding to this event A. They will have here 6 points, that both the dice have either 1, 2, 3, 4, 5 or 6 numbers on their upper faces. On the other hand, in case if my objective is something else, then I can define another event here B, which is the sum of numbers on the upper faces is 6. In that case, the sample space corresponding to this event is defined as, for example, now this omega B can have 6 possible points: 1 5, 2 4, 3 3, 4 2 and 5 1. And if you try to see, if you try to sum any of these two numbers, their sum is always 6. And then similarly, if you wish, you can define so many events and from this capital omega, right. And in this case, a sure event is get either an even number or an odd number. Definitely you are going to get one out of them. So, this event is 100% guaranteed, or this is a sure event that will always occur. And an impossible event would be like the sum of the two dice is greater than 13. It is not possible, because the maximum value which a die can take as the number of points on the upper face is 6. So, the maximum value will be 6 and their sum is going to be 12. 13 can never occur, at least in this case. So, that is going to be an impossible events, right. So, now we come to an end to this lecture. You see, this was a very simple lecture, just trying to introduce you with the basic notations of sample space, events, etc. But definitely they are very important, because whenever you are trying to work in the decision science, whenever you want to compute the probability of something, these are the basic ingredients. Unless and until you define your omega, omega A, B, etc., how can you compute the probability? And these definitions are in your control. The person who wants to know the probability of certain event, that person knows, but that person possibly doesn't know statistics or data science. That person will come to know only to you. You have to listen and you have to translate what the person is trying to say. For example, if I take the example of this medicine, you have to decide what will be the range of the dose of medicine: minus infinity to infinity, 0 to infinity, minus infinity to 0, some integer or some real number, whatsoever you want, you have to decide. And one thing is this: whatever you decide, you have to match with the real thing, what is happening in practice. If you try to say the doses are going to be integer value, that means there are only some tablets. But if there are no tablets, but there are some liquid, and that liquid can be given in any volume, then definitely the dose can be 2.3 and 2.4 ml also. But you have to take a call, and for that you have to understand what's really happening. And I always say that a good statistician will be that fellow who is a very good social scientist. You cannot say that I don't know how the doses of medicines are given. So, you try to understand these things, try to take very simple example, try to think and try to construct your own sample space and events and get confident. So, you try to do it, and I will see you in the next lecture. Till then, goodbye.